Okay, this video will show you how to find to prove the convergence or divergence of a series like that. And this is in chapter 9.6 on ratio test. So obviously the best method will be the ratio test. Plus this is an exponent 5, 6 to the n, and ratio tests are very good with things like that. So the first thing we need to do is to find the limit of this quantity over here. Okay, because an is on the denominator, so you have to take this thing which is called an and flip it. So if you flip this, you will get 6 to the n, 5 to the n, and n squared is on the denominator, like this. So we are actually taking the limit of an plus 1 over an. I've written down what an is because this is an, and I flip it. And for an plus 1, I'm going to have to put n plus 1 every time I see an n. This is what it is. So some students do it a little differently, and they saw this thing and they took this and got a wrong fraction instead, and that's very dangerous. If I were to do cancellation, this thing cancels and I get only 5 on the top. This thing cancels, I only get a 6 on the bottom, and I will get limit as n goes to infinity 5, 6, and an n plus 1 over n quantity square, like this. And this actually is a lot easier to do than to expand the top square and the bottom square, because you see what this simplifies to? I'm going to erase it and show you. 1 plus 1 over n. And so in the limit, as n becomes bigger and bigger, this is just 5, 6, 1 plus 0 square. And that's 5, 6. And 5, 6 is less than 1, isn't it? 5, 6 is less than 1. So by the ratio test, our series n squared 5, 6 to the n converges. Why? Because 5, 6 is a number less than 1.